Welcome back. And we are now going to study what we call exploratory data analysis. So you have gone through, you've posed a good research problem, it's well defined, you've collected your data properly, your sample is large enough and representative of the population, and now you're ready to start to analyze the data. What do you do? And so I want to try to give you an idea of the challenges for exploratory data analysis by showing you a data set that we're going to analyze in class. What do you think of this data set? Pretty neat, huh? Well, probably not. It's probably confusing to you, and it should be. Remember, we said whenever you have a data set, the first thing you have to know before you do anything with the data is you have to know the context. I want to know what these variables represent and how was this data collected. So I'm going to fill you in on the context. Let me show you the actual context for this data set. This is a data set for the passenger manifest of the ship called the Titanic. And so we have 1,309 passengers. In other words, this is our sample size. It's huge. We collected 14 variables on all of these passengers. And this is the source. And this tells you the variable coding. Okay, so P class is passenger class. You might have guessed that. Survival, okay, yes for 1, no for 0. Then the name of the people, their gender, their age. I mean, there's a lot of information down here that's probably not important to us. Okay. So the first challenge with data sets is we see that they're huge. We have to somehow summarize and boil them down. And how do we do that? We do that two ways. First of all, we plot the data. You've heard the old saying, a picture is worth 1,000 words. Well, it's certainly true in data analysis. But plots alone are not enough. I mean, if your boss gives you a data set and says plot it, and he sees you in the elevator that evening, oh, what's that data set look like, Johnson? And you go, well, it kind of went up and then went down and then went up again. You know, plots are too qualitative in nature to really give us a good, hard description of the data. So we're going to supplement that plot with some numbers that we compute from the sample. These are called summary statistics. Recall, a statistic is anything we compute from a sample. So we're going to compute numbers from the data set that capture some of the main features of that plot. And we're going to talk about what those are later on. So we plot, we compute statistics that describe the plot, and we put it together. Sounds pretty simple. But there are a couple of problems we have to deal with. First of all, we noticed that we don't need all of these variables. I'm probably not interested in the home destination. So very often when you work with large data sets, especially those that you're going to download from the internet, you can eliminate a lot of these variables. So I might just delete all of this. And I probably don't even have to know the name of the people. Although some of them are interesting. You can see that the Astors, who are a very famous rich family, are on there, and I'm sure many others too. But for our analysis, I'm not going to worry about that. Now I have this data set down to a couple of variables. So sometimes we have to deal with, getting rid of extraneous variables or things that we're not interested in studying. Notice another problem is missing data values. What do we do with those? Notice also there are possibly questionable data values. Okay, is this person really 0.9167 years old? So we have to talk about that. These are sometimes called invalid data values. So we're going to have to deal with invalid, missing, and outliers. These are going to be 3 classes of data values that we're going to have to give some consideration to. But let's suppose we've cleared up all of those issues. Now, what can we do with our data? What can we analyze? Well, the answer depends upon how many variables and what the data type are. So for example, I could just look at the percentage in each class, right? If I just looked at one categorical variable, or I could look at the percentage who survived. Or if I looked at a quantitative variable, I could plot all the data variables and I could look at the distribution. Like if I plotted all the ages, I could see the range of ages the passengers had, and I could see how likely it is that a passenger fell in a certain age range. So these are two different types of analyses between quantitative and categorical. One variable is generally not particularly interesting though, so we might want to look at two variables. And when we're analyzing two variables, if we have two categorical variables, we'd be looking at what's called an association. In other words, is passenger class and survivorship associated? That is one passenger class more likely to have survived than the others? I could look at gender and survivorship also. There might be an association there, okay? And so this is one thing we can look at, associations between categorical variables. If I looked at a categorical and a quantitative, I could look for differences in different groups. So for example, I might look at gender and age, and I might ask, were females younger than the males? That would be an interesting question also to consider. If I had two quantitative, I could look at correlations. And we're going to get into the details of how we make the plots for these different types of analyses and what it is that we're looking for and how we actually carry out those analyses. And fortunately for us, we're going to be able to use StatCrunch. So StatCrunch is going to make things considerably easier for us. All right, well, I hope that gives you kind of a brief introduction to what we're going to do, some idea, and that you enjoy it. Thanks.